Welcome to Machine Learning and Digital Hub webinar. Let's just start the event off by mentioning a few housekeeping tips. Please utilize Q&A section to ask your questions. We will answer them during the webinar as long as the time allows. And for further discussions, I encourage you to join our webinar Q&A group on the community at community.digitalhub.io. Please notice our following legal disclaimer. Material presented here, including but not limited to text, images, and codes, are subject to Digital Hub terms and conditions and are for demonstration purposes only. This information may include future product features and plans, and sharing, copying, reproducing, and modifying them in any form requires Integra's permission. Let's introduce today's presenters. I'm Hoda Rezai. I have Babak Shafi, Integra's founder and CEO with me, and Sylvia Lee. Thanks to all of you, we have seen huge interest in our oil and gas data science series webinars. And for the upcoming one, which will be on February 16, we are going to present a time series data analysis use case. So please make sure you register for this webinar as well. And with that, I'm going to hand it over to Babak for an overview of Integra and Digital Hub platform. To you, Babak.
Thank you, Ola, for the introduction, and good day, everyone, and welcome to our third webinar. Lots of interest and lots of excitement around these webinars that are focused on oil and gas. If you haven't been into our previous webinars, I'll just take a couple minutes to introduce Integra. Integra is a small consulting company focused on solving real-world problems in the oil and gas industry. We come from that background, and we felt there was a need in the industry for a focus group on oil and gas problems. It's a broad domain. We work on upstream SAGD operations. We work on midstream, pipeline integrity, pipeline efficiency, energy management, and some activities in downstream. We're focused and right now located in Calgary, Alberta, which is the hub of oil and gas industry. I'm very proud to be part of the city and part of this community, and we're really hoping to lower the barriers to entry for AI and ML. We truly believe in the power of AI and ML. I have personally experienced it back when I was part of a corporate and founded Integra to create more momentum in that space. At the moment, over the last year, because of the COVID and everything else that happened in the industry, we changed our focus a little bit onto a platform that we had internally. We use this platform for a few of our projects, and we decided that we should make this platform available to everyone. What we wanted to do with this platform was to bring innovation that happens in data science and on laptops to cloud scale and on-demand capability. And we call it Digital Hub. So that's the story behind the Digital Hub. We're also active in the community, big advocate of learning and development. Our platform has free subscription plans for students. We realize that a lot of people and a lot of engineers will be transitioning from what they used to have in terms of the toolkits to the new toolkits. And we wanted to make this available. So if you are a student or if you are an engineer going through any course and you are a student, you will have a free plan on Digital Hub. Can we go to the next slide, please? We wanted also to highlight areas that we had success, huge success, as well as share other materials that we're going to be sharing in the future, demos and concepts. The whole idea here is that if we don't work, all of us, if we don't work together, we won't really be able to change this industry. And that's what is really near and dear to our heart. We want to change this industry. We're a small force, but we're really practical. We have focused our entire time, day in, day out, on solving real world problems. Not marketing our work, not marketing, which model to use, but really to solve it. And these are some of the examples on drilling optimization. We have solved big data, high frequency data, and how to deal with it. And we will be happily sharing that on our community and in upcoming webinars. Optimizing the well productions. Some of the gas wells that are nearing end of life, how do you optimize it? How do you maintain the productivity of the well? Pump failures is a very common use case across the industry when it comes to predictive maintenance. Water filter anomaly detection, understanding what impacts your water plant and what impacts the filter anomalies. Pipeline simulation, that's a very innovative solution that we have developed. And what it does, it uses simulation to predict and detect pipeline failures based on certain criteria and standards that are existing in the industry today. And looking at the flow optimization, that again, another use case in that area of midstream. We are providing these examples and it's on our website. So Integra.ca is the consulting website and digitalhub.io is the platform website. We would have these use cases and the details of them on our website. Feel free to request a demo if you are interested in any of these, or if you are in a different industry and you want to translate, how you could be using some of these, we're happy to share. Can we go to the next slides, please? So what is Digital Hub? Really, we think of it as a game-changing toolbox. So we wanted to make sure a few things happens first. Cloud first, right? So broaden a cloud-native infrastructure. The second element that was really important to us was cost. I realized from my corporate days that it was very expensive to do any data science projects. It required a lot of different disciplines to come together from a human source perspective, but also from a technology perspective. We needed to have quite a bit of different selections to make in order to run a digital or a data science project. So we wanted this to be very cost effective and scalable. Like in some cases when we were successful, we couldn't really scale up the solution. So these three things were in mind when we built a digital hub. You would be able to access it through just a browser. It's very cost effective. You can turn it on and off, and you only charge it for when you're using it. So if you don't need to pay for the infrastructure you don't need. So if you use it for a few hours, that's how much you would be charged. And if you can turn it off, you can bring other people, you can create a team, and I'll go a bit into more details of the platform overall. And we will be having webinars that gets us more into what the digital hub does for you. Next slide, please. So who did we have in mind? Big corporates obviously have big teams, and there will be no shortage of platform that they can acquire. So that's fantastic. But we had a few different groups in mind. We thought about engineers and individuals. So if you are a freelancer data scientist, where are you going to do your work? Is it going to be on a laptop? Can you really create a work that is scalable? We know it's not possible. We tried it. We were on laptops ourselves, but our data scientists will run into many issues of versioning and scaling. Maybe you're using just a laptop. So individuals, we targeted individuals. We want this to be for individuals. We kept it low cost for a very low fee on a monthly basis. You'll have access to the platform. And you don't have to worry about the setup or anything. Everything is already pre-packaged. Everything is ready to go. Then we thought about the small businesses. Like in every industry that I've come across, data science and working with data is becoming really, a necessity. It's almost like Excel. Initially nobody used it, but then eventually everybody knows a little bit of Excel. So data science tools are more or less like that. And we're focusing on the small businesses because for them to catch up to the learning curve and to set up the environment and what platform to go to, which one to choose, we wanted to remove all of those technical barriers and get them going. So if you are a small business, either consulting as a service to another industry or even to oil and gas industry, or if you have a small team inside a big organization that you're just getting started and you want to get your hands on some data science without having to worry about how to set it up, this is for you. And on the enterprise, we have created features that can significantly reduce demand on the IT organizations by offering on-demand and scalable and very cost-effective self-service project creation through the process. So these are the three types of users or groups that we thought about. And I know there are many of industry leaders on this call. And I hope that this resonates with you. And I want to say, please do reach out if you have any questions on LinkedIn or other email or here on the Q&A. I would love to work with every single one of you. I would love to share what I have learned and what we have learned as a group, a small consulting, previously in the corporate and then a small consulting, and make this, advance to the benefit of all. Can we go to the next slide? Some of the features that we like to highlight is obviously convenience. I took some courses at MIT. I did some big data courses, primarily on social analytics. And I remember what I had to go through to set up the environment, have the right packages. And then later on, after the course was finished, I changed my laptop, I changed job, and basically I don't have access to those codes anymore. We offer, a cloud-based access, so you can always log into it. This will always be there. Your files will always be there. So it's convenient. The environment is set up. Everything works together. And you would have admin access, so you can make changes if you wish. And if you break one project, no problem. We create another project. It's not going to be a significant task to do another project. The scaling was important for us. So coming to Kubernetes and Docker, we wanted to make sure that it's scalable. So as you grow, you can create more projects and each project can scale. Teamwork was important. You can invite team members. So if you have a small consulting or you have a small number of people who are supporting your project, but you are the project owner, you can create a project, assign individuals to that project, and they will be sharing the same code, the same material, the same environment. And you can create another project and it will have a separate security system, it will have a separate integration with databases and so on and so forth. This will allow you to create the teamwork and separate the data. So if you're in a bigger organization and you want to separate, HR data or health and safety data from your finance or your supply chain, you can easily create different projects for each of these groups. Or if you have if you're a freelancer, you want to create different projects for different users, you can do so. Big data is also very important. We had to deal with big data and high frequency data, so we included that. And another thing that we've done, this is not just a data science. Like, we've been focusing on the data science features of the platform, but it's also a business intelligence platform. We have two really good tools, monitoring and business intelligence. For monitoring and business intelligence, so creating dashboards, telling your data story. And all of these components share the same database for each project. So within a project, when you create a data science and BI and monitoring tools, they all work together off the same database, which is very nice, because what we found that we had to do the work, do the data wrangling, pipelining in Jupyter, and then move that data into a database where our BI tool was connected to. But here everything is connected. So the same data, you can data from your monitoring system, manipulate it, and then visualize it in the BI tool. So all integrated into one package. So this is some of the features. I'm going to, if you can go to the next slide, just talk about the pricing. These are the early pricing. We hope that everybody should be able to afford this and everybody should be able to sign up, support our growth if you like it, if you like these webinars that we're providing, if you like the information, support us. We will put every gain in the platform back into the platform. That's our idea. Individuals for $14.99 and team for $29.99. And we can talk about any team that is more than 5 people on custom plans. These are early pricing. We're still trying to get to a point where we have appropriate pricing for the platform. I suggest that you secure your early pricing as soon as possible. And like I said, this is a very small amount. Next slide. With that, I'm going to pass this on to Sylvia to take on the use case we're going to present today on the platform and go from there. Sylvia, to you.
Thank you, Babak. So hi everyone, I'm Sylvia. So I'm a data scientist working in Integra. So today I will be presenting you with a use case that we've done using the Digital Hub platform. So this use case is based on electricity generations optimization in terms of how much load you should be producing based on the market data that you can get from AESO in Alberta. So we'll also be using the machine learning in here and then showing you how you can apply some like simple logic to get some very valuable insights from your data set. So for those of you that have seen our last webinar series on machine learning, some of the machine learning parts may be revealed to you. And then we'll also try to, as we go through the machine learning part, answer some of the questions that had come up in the last webinar series. We do have our site just at cloud.digitalhub.io. You will be able to access the login page here. If you don't have an account yet, just click on the sign up and you can register here for us. So going back to the login page here, I'm just going to sign in quickly. So the first thing that you see is going to be a homepage. So on the homepage here, I'll be able to see projects that I've created myself or projects that have been shared with me by someone that might have a Teams subscription and they've invited me to their Teams. They can have a list of projects that will be shared with me. So inside every single project, I'm going to show you Digital Hub. We do have project as kind of our unit of deployment here. So you can very quickly create a project in just a few minutes. So I can show you quickly the process here. You can look into a data exploration if you're just looking to do some EDA on your data sets, or a specific machine learning environment to develop machine learning models. So say this time we're having a machine learning webinar series, so I'm going to create a machine learning project. So next, we do have some components that is suggested that we've integrated into the platform that you can just quickly deploy. So H2O along integrated into the Jupyter IDE is something that for a lot of data science interface we use as Jupyter. Superset and Grafana are the two dashboarding and open source monitoring deployments that we've integrated, as Babak had mentioned, for business intelligence to deliver your results to others. So the next part, I have a team subscription on my account here, so I can quickly add members just by inviting them. So let's say I would add Babak to my project here. I'm gonna give, say, an owner role, and then I'm going to add Huda to my project. So I'll give a reader role. So after I've completed assigning like who is going to be part of this project, I can just quickly complete the submission with a nice project name. Let's say it's machine learning. And with a good description. And add some new text in here for later on to like just an easy search of your project. I might do some EDA, some machine learning, and just click create. And your project is going to be underway and it gets deployed. So if we go into the project details page, you can see that things are going to be provisioning because we do launch up a separate deployment of every single one of these applications for each of your projects, along with that database that integrates all of them together. And then so that way to keep all of your projects segregated from each other and reduces the chance of like data contamination or security problems. So for the sake of this demo, I've already created a project that I can show you the machine learning on. I do have my components here. I wasn't using Superset and Grafana, so I have them post here so to manage my cost, but I can just very quickly start them again or post them again as I desire. And for this series, I'm going to show you specifically in Jupyter. So once I've launched up my Jupyter, it was already running. So launching on my Jupyter, you'll be able to see the homepage here that we have a few kernels already integrated for a few common data science languages. But specifically, I want to highlight to you the template section here. If you choose a Digital Hub, this is where you can actually find a lot of the notebooks that we have been demoing to you and then look through them. And then specifically, you can just go and then launch it, and then it will create a notebook for you. But for this project, we also have on my homepage here, I have a few of my own repositories that on projects that I've been working on, but I can also go into the project folder here. Quick connection issue here. So now I've navigated into the project folder. So this is a shared project among all of my team members. So when your team member actually comes in, say, hold up or backpack launches up their Jupyter, they will actually be able to see all of these files under the same project folder for them to look at. So in this case, I'm going to run my notebook folder here. For the sake of time of this demo, I've already run the entire notebook beforehand to show you the results. So what we're going to be doing is actually we have a use case for electricity generations. We have a sensor on the power plant that gives us some information and data, hourly data on the ambient, so just the environment, so the temperature, the humidity, and now our problem is to see how we can use these sensor data, estimate what it's going to output for that hour, the electricity amount that's going to be output, and combine it with a market data, forecast data that we can get from AESO to give us back some recommended actions of what we should do with that hour and the energy production at that hour. So our data set, they actually are open data set that you can get from the UCI, machine learning repository, and from AESO. So first we launch up a few of the libraries that we have already installed for you onto the Jupyter Lab when you open it. So a lot of the common data science libraries that you would likely use. So these are the importing with a data set. So you can see in the data set here, we have the ambient temperature, exhaust vacuum, pressure, humidity, and the hourly energy output. So this is a data set that we have for 6 years in the past, and then for hourly data. So we already have the energy output. So that means what we're actually going to be doing is a supervised machine learning. So because of time, I'm just gonna run very quickly through this part here. If you have seen our previous webinar, you'll be familiar with the pandas profiling library where you can get a very quick EDA on all of your variables and also in terms of the interactions and correlations between your variables. So it's very informative for you when you're doing your data exploration to kind of get an idea of what is in your data set. So next, in advance to what you've seen in the notebook for the last series, I've added in a lot of tips in terms of the process for data machine learning. So to know, we also split our data into training, testing, and validation sets for the machine learning, just to make sure that we reduce this optimization bias as much as possible. You can go into the notebook and read in a little bit more details in terms of that and how that process whole looks like. But the whole idea is that you don't validate your model on data that they have seen before. So then while we're doing a lot of machine learning tuning and modeling, trying to get the best model that we can get for our problem, it's going to have seen your training data many, many, many times. So you will want to always leave out a section of your data for validations, a set of data that your model's training have never seen before for that validation. In addition to last time, we also have gotten a forecast data from the AESO for according to the time that we want to actually make some market analysis and predictions. So lots of this now, we would then, the package that we're using for machine learning is called H2O. So H2O is an open source library for machine learning and machine tuning, helps us do a lot of the auto tuning of the hyperparameters. So then we can quickly train our model, so what this package does really well is that it gives you back a leaderboard of all the different models that you've trained, and then it gives you back the model that it thinks has the lowest, it trained and had got the lowest error rate. So then in this case, as a data scientist, I might come in and look through the models in terms of what model I want to use, because sometimes even though it gives you back the model with the smallest error rate, sometimes it's the model algorithm itself. So it will very much depend on what problem types you're solving. If your machine learning model is going to be just one part of a very big pipeline, there's a lot of other considerations that you have to make in terms of computational resources, how important it is for you to be able to explain how it got that result. So if I want to actually be able to explain how it got, say, a prediction result, maybe a deep learning is not a very good model to use. if that is very, very important to you. And also it actually depends on the amount of data that you would be able to have on the training set. So in terms of our data sets here, we have a relatively small data set. A lot of these deep learning models that it has given to us, we're not going to be able to use. So in this case, let's say we choose just the first one, XGBoost, which is a very common model for a lot of the regression problems and also for classification problems. We just use that model to continue with our analysis. We can see that there is a, one thing that it shows very nice is that it will give you back the variable importance. So which variable inside your data set is actually the most important in terms of giving you that prediction. In this case, I see that there's the exhaust vacuum pressure and my temperature seems to be contributing to my predictions 50% and 45%. So in this case, those two, in this part, sometimes you can get some very unexpected results, which can lead to some very interesting analysis, or in this case, we've pretty much expected that to be the case. You can also show a heat map in terms of all of the different models that it's trained for, and then how much importance of each feature is to that model. Next, we're going to predict it on test data. So this is part of the validations of your model to see if you are doing any overfitting, underfitting, making sure that your error rate here is quite similar to your training error rate to ensure that you're not going into any of the optimization bias or any deviations away from a model that you want to have. So in my case here, I just did the extra validations on my model with the validation set, and I have done the predictions of it, and then just quickly visualize my residuals to see how this model is performing. I know that for the, and also a visualization of the predictions versus the actual, and just some visualizations of these are the two important features that the model have set to be correlating deeply with the energy output predictions, and just more visualization. But now let's get to the new part very quickly. So we have I have left out a week of data that where I would want to do a market analysis with. So in this case, I've taken out the energy output column from it just to imitate what kind of data you might get after you've changed your model and you actually put in your model in use. So then every single hour we're getting these features. We plug it into the same model to get our energy output. Just a few course of 9 really. Machine learning is not hard. So then I would just get the predicted energy. And now we have our AESO data, and then we merge the two data sets together. So now we have a data set where we have the output predicted energy for that hour and also the forecast price of the pool price from AESO for that hour. And then so what I've done really quickly is to just simulate what kind of internal demand that I might have for that power plant. So this is the internal demand that I need to have generate for that hour for my power plant to be able to run, or like for the rest of the business product that I might need to produce to be able to keep things going. In this case here for this demo, we've implemented a very simple logic in terms of how we can generate those recommendations. So just in comparisons of the cost price, we do know that we've gotten from the EIA reports that it's about 3661 for a combined cycle power plant to be able to produce 1 megawatt hour. So then like in comparisons to that average with your forecast price from the AESO for the pool price, are you going to buy your demand from the market or going to sell your demand to the market, sell if you have any surpluses? So then in terms of your production, after we've estimated for that hours, you might have a shortage of a surplus. If your cost is actually going to be less than the price on the market, then you can either produce or produce your surplus, sell to the market, or if you have a shortage, to just produce what you can and buy from the market. This is a very quick and simple logic on here with more expertise in terms of like how the market works and in terms of different analysis. Of course, these can be a lot more intelligence in terms of the output and the recommendations you put. And at the very end, I just using the estimated power plant predictions, and with that logic from the market, presented a recommendations here to whether you should buy or sell your energy from the market. So with a very quick visualization of just that 1 week of data hourly, what's this estimated when you will actually have a production shortage versus a surplus, and also given that production shortage or surplus and the estimated energy that you can get in comparison to the market price, what is the most recommended action that you can get? So you can either buy your full load from the market or produce as much as you can, buy the shortage, produce all that you can, and then sell the surplus to the market, and then coming up with your estimated net cost for that hour and the actions. So with these, it's actually, you can combine a lot of different analysis for some very insightful and valuable outcomes out of your analysis here. So that was a very quick demo of the notebook, given the time. If you have any questions, feel free to join us on the community here. So at community.drjob.io, we do have a webinar Q&A group. You can post your questions there or inside the Q&A in this webinar here if you want to stay a little bit longer. We can try to answer as much as we can. But that would be it for this demo. I'll hand it back to you, Babak.
Thank you, Sylvia, for managing. I know we have 4 minutes over time. I do want to thank everyone personally. I appreciate the questions that came up. I will stay online a few more minutes for anyone who has any questions, but this is officially at the end of the webinar. There will be future webinars that we'll be looking at the time series. And like I said, our goal is to showcase how you can use data science to solve some of the real world problems. And this is a real world problem. We are producing electricity as various sites in our oil and gas setting, and we need to be optimizing it based on the market conditions. So stay tuned for additional webinars. And thank you again for joining us. If you have any questions, reach out to me on LinkedIn or via email for any opportunities that you want to discuss any further. Thanks, everyone.